So yesterday we implemented add, which was fairly involved. 4 steps had to be done in a specific order. Lots of references to something.next. Today we're going to focus on remove. So again, we want the same behavior as the Java standard library. When we invoke remove, we have to have just called next because the element that's removed is the one we just iterated over. Okay. I hope that this will be insightful as we kind of do a couple of things in here. Um, so let's take a look at a picture first. So here we are. We're going to handle, again, different cases. First case we're handling here is the case where we have a new, where we just iterated. We made a new list iterator. We called next. And so we just iterated over the first node, meaning the node whose data is Diana. And we're about to call remove. So when we call remove, the node whose data is Diana, this is the node that's being removed. And we have to clean everything else up as a result. So here's what it should look like after the fact. After we remove Diana, the first node in our linked list is now the node that refers to Harry. And our linked list iterator position is back to null because we're like back at the start of the list. So that's the behavior we want. So we're starting here. We have just called next and iterated over the node whose data is Diana. We now call remove. The node containing Diana is gone, unlinked from the list, and first needs to refer to the node whose data is Harry, which we can get at from first.next. And our list iterator's position is back to null, specifying it's at the start of the list. So let's see what that looks like from a code perspective. So right now we're just focused on the boundary case of like it's the first node in the list. All right, first things first, we need to have our method header, public void remove. And then we need to make sure that we just called next. This is why we have this instance variable is after next. So let's check this first. If not is after next, we will do the same thing the Java standard library does. We will throw a new illegal state exception. So the special case we're dealing is when we're removing the first node in our linked list. The good news is we already wrote a method for this. Where is that at? You're all up here. We already wrote a remove first method. We can just call this if we're removing the first node in the linked list. So let's check for that condition. If the position of the iterator equals first, then we are about to remove the first node in our linked list. So we can just call the remove first method and then set position to null, specifying that our list iterator is now at the beginning of our list. So removing the first node from the list is a little bit easier because we already wrote the code for that. But what's going to be a little bit more challenging is the else block. Okay, so this will be the generic case of we have called next. We've just iterated over some node in our linked list, and that's the one we have to unlink from the list. But it's a little bit more complicated when it's not the first node in the list. So here's a picture. Let's look at the picture first. In this case, the iterator's position refers to the node whose data is Harry. That means we just called next to iterate over the node whose data is Harry. And so when we invoke remove, the node whose data is Harry, this node is going to get removed. And so you can anticipate that this is a little bit more complicated because we have to unlink this node, which means changing like several things. So let's look at what it needs to look like at the end. Okay. Again, broken down into 3 steps. First step, the node whose data is Diana. This is the node before the Harry node. This next now needs to refer to the node after Harry. It needs to refer to the node whose data is Romeo. So we have to change this reference here. Now, a couple of things that we need to be aware of is how do we get a reference to the node whose data is Diana? Well, that's what previous is for. The previous instance variable of our list iterator refers to the previous node, the one before the one we just iterated over. So we can say like previous.next equals position.next to link Diana's node to Romeo's node. So that's step 1. Step 2, position has to be set back to Diana. Okay, we can't leave position referring to Harry because this node is gone. It is unlinked from our list. We have, essentially in terms of if when we call next again, we would iterate over Romeo. Therefore, position needs to refer to Diana. Okay, and then we'll set is after next back to false. So 3 steps to pull this off. Let's look at each of those in turn. First things first, previous.next equals position.next. That's step 1. Then we set position to previous because otherwise it would be referring to a node that's no longer in our list. That would be problematic. And then finally, and we always need to do step 3, regardless of whether we're removing the first node or not, we will set is after next to false. And that's step 3. Here is an important question that I want you to, on your own, think about for 30 seconds and then talk to your partner. And that is a question that was raised back in the previous chapter, but I think now we are equipped to actually answer it. Why can we not support invoking the remove method twice in a row? So I'm going to leave the code on one screen and the diagram on another screen so you can look at both. Why can we not support invoking the remove method twice in a row? Think on your own first and then discuss with your partner. All right, discuss, share. What do you think? Thoughts? Any pair want to share why they think we can't do this thing? Luke? I think you're on the right track because position. So Luke said because position and previous refer to the same node, but we have a reference to the node whose data is Diana. Could we not just unlink that node? Where would we run into trouble if we try to unlink Diana in this example? Maybe this isn't the greatest example. What could be the case? Maybe not in this picture, but say that again. I'm sorry. Yeah, I think so. Let's say, like, pretend this example is slightly different. So I'm going to add a node here before Diana, and we'll have first refer to this and next refer to Diana. How does that complicate things? If we want to unlink Diana, what challenge do we have? Why is it not possible to unlink Diana given the current state of our iterator? Yeah. Yeah, there's no way to get to the other node, right? Previous refers to the previous node, but there's no like previous, right? So if we wanted to support calling remove twice, we'd have to have previous and previous, like an extra instance variable. And if we wanted to support calling remove three times, we would need previous, and previous, and like it becomes unmanageable. So instead, the designers of Java were like, okay, well, we'll only support calling remove once because now we have a reasonable number of instance variables. But this is why there's that behavior that we studied in chapter 15. Now we hopefully appreciate, like, oh, I get it. Like, we just can't get to the previous node. We have no reference to it. So that's why we can't call remove twice. That's why we're going to throw an illegal state exception if we end up in that situation. So, all right. We have one more method. This method's easy. Set. Public void set. It takes one parameter, which is a reference to an object, because again, we're not doing generics right now. It's the new value for the node that we just iterated over. So again, the behavior of set is we must have called next before we can call set. So if not is after next, we're going to do the same thing we did before, throw a new illegal state exception. But otherwise, it's super easy. We just say position.data equals element. We can call set multiple times in a row. So we don't want to set is after next to false, and then not be able to support that behavior. So really, as long as we just check that we've called next, and then we just update data to reference the new element. That's it. Not so bad. All right, I do want to share with you like a little tip that might make your life easier. Um, I meant to mention this previously and just forgot. Sometimes our code is kind of a mess and like our indents end up all off and it's hard to see like where the brackets might line up, and even though they're color coded in lines, it can be tricky. You can reformat all this stuff. And so a couple keyboard shortcuts that are really helpful, I think are really helpful. On Windows, Shift Control P brings up the command palette. On Mac, it's Shift, I don't know these keyboards well. Shift Alt P, I think, will bring up the command palette. And then all your commands are here. And there's a huge, ridiculous number of them, like scroll, 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 scroll. So you never scroll and find what you want. Instead, you just type a word or part of a word that's relevant, like format. and it will filter out all the commands that have something to do with formatting. Um, and so I'm just going to choose format document here, and it's going to like clean it up and make it look nicer, which is great. So that's like an easy way to bring up the command palette, which you can also get to through the view menu, view command palette right here. But formatting your document can help if things get a little unwieldy. So at this point, we've implemented our iterator. We can switch over to list demo. We can actually uncomment all this code. Again, control/ on Windows, alt/ on the Mac. Um, and now you have some sample code that actually creates our list iterator, calls next. I'm still using the same annotation from chapter 15, where we visualize the iterator between two elements, but now we know that's not really the case. It actually refers to the node that we just traversed over when we called next. So next adds, next remove, creating an iterator, using has next, printing everything out. You now have a full working example here of the linked list iterator. So I'll save that.